we consider another collision problem where the objects actually, I'll put in parentheses, stick together after the collision. So I have a 4-kilogram fish that's swimming at 3 meters per second to the right, and it swallows an absent-minded 1-kilogram fish that's swimming towards it to the left, and it has a velocity of 2 meters per second. We want to determine what is the speed of the combined fish system after the collision, or after the little fish is swallowed, and we're going to apply conservation of momentum, and we have to make sure we're very careful of the signs of the velocity, and we need to take into account the directions. So if we look at what's given, we know the mass of the big fish is 4 kilograms, and we know the mass of the little fish is 1 kilogram. In terms of the initial conditions, it says that the big fish, or the 4-kilogram fish, is traveling at a speed of 3 meters per second to the right, so we know the initial velocity of the big fish is 3 meters per second. And we also know that the 1-kilogram fish is traveling to the left, and it has, this really should say, a speed of 2 meters per second. So in terms of the velocity of the little fish, the velocity is actually negative because that little fish is traveling to the left, so its velocity is a negative 2 meters per second. In terms of the final conditions, the big fish swallows the little fish and they travel together after the collision, and so the final velocity of the big fish is equal to the final velocity of the little fish, and that just is some value. So this is essentially a perfectly inelastic collision, and we know that the momentum before the collision has to equal the momentum after the collision. So if momentum is conserved, then we know that the total momentum initial, which is the momentum of the big fish initially plus the momentum of the little fish initially, has to equal the total momentum of the system after the collision, the final momentum. We can write the momentum as mass times velocity. So this is the mass of the big fish times the velocity of the big fish initially. And if I add to it the mass of the little fish plus the velocity of the little fish initially, that has to equal the total mass, because they are now stuck together after the collision, times the velocity. So the big fish has a mass of 4. It has an initial velocity of 3. I have to add to it the mass of the little fish times its velocity, which is negative 2 meters per second, and that has to equal the total mass of the system combined, because they are stuck together, times the velocity. So the initial momentum of the big fish is 12 kilograms meters per second. The initial momentum of the little fish is negative 2 kilograms meters per second, and that has to equal the mass times the total mass times the velocity. So if I add the initial momentum of the big fish to the initial momentum of the little fish, I end up, the total initial momentum of this system is 10 kilograms meters per second, and whatever the initial momentum is, that has to equal the final momentum, which is the total mass times the velocity. So if I divide both sides of this equation by 5, I get that the final velocity of the fish combined together after the big fish swallows the little fish is 2 meters per second.